What does it mean to be a maximum or a minimum? Well, maximum means a greatest value, right? And a minimum means a smallest value. So if I drew a graph here, in this little area from here to here, I have a greatest value and I have a smallest value. But over the whole graph, if this is continuing, I don't really have a maximum or a minimum because it goes on forever, so I don't know what happens. So for a maximum, we'd say that a function f has a local maximum at c at some point c. If there's, now I have to have an open interval. Open means there's no endpoints. And we call that I. That has c. So c is in that I. And we have all x on the interval, for all x on that interval I, the values of the function are less than or equal to the value at that point c. And then the value f of c is that local maximum. So c gives us the point, and f of c gives us the value. So in this, if I have an open interval, if I'm looking from here to here, and I'm not including the endpoints, my local maximum would be right there. So my x value would be, so let's say -2, and my y value would be 2. Local minimum is the same idea. I could look at that same graph again if I wanted to. If I look at the interval from here to here, there is my local minimum. And it's the same type of definition. So I say a function f has a local maximum, a minimum, at some point c if I have an open interval call that I, where c is in I, and for all x in that interval I, the value of the function is greater than the value at that point. And then my f of c now is my local minimum. There will be my local minimum. Now it has to be an open interval because otherwise we'd have to consider that. Remember, open means as close to that point as possible, but not there.